Alright, welcome back, guys. So, chapter 15, quantity of heat, heat capacity and latent heat. Number one, okay, quantity of heat, heat capacity and latent heat. Number one has to do with calculation. Number two has to do with calculation. Let's go move on. There are a lot of calculations in this chapter. Number two has to do with calculation. Three, the following are some units. You get the following are some units. We are given different units. What is the unit of latent heat? Option E, joule per Kelvin. J kg raised to power minus 1. 3 is option E. The amount of heat required to raise the temperature of a body is called thermal capacity. Number 4 is option E. Number 5, calculation 6, 7. The latent heat of fusion. 7. The latent heat of fusion. Right. Latent heat of fusion is the heat required to change a solid to a liquid. Next, latent heat of vaporization is the heat required to change a liquid to a gas. You see? So 7 is option C. Change it from solid to liquid at constant temperature. 8. When equal weight of iron and water are subjected to equal supply of heat, it is found that a piece of iron becomes much hotter than that of water after a shorter time because the specific heat of water is higher than that of iron. The specific heat of water is higher than that of iron. So iron will become hotter than water at a shorter time. 8 is option D. 8 is option D. 9 is calculation. 10, calculation. 11, 12, 13, 15 is also calculation. 16. Let's go. The specific latent heat of fusion of lead is the amount of heat required to melt it, change it from solid to liquid. So 16, the specific latent heat of fusion is the amount of heat that would change the state of the mass at its melting point. 16 is option C. 17, calculation. 18, calculation. 19, the same thing. 20, the same thing. 21, the amount of heat needed to raise the temperature of 10 kg of copper by 1 Kelvin is 10 kg of copper by 1 Kelvin is, right everyone, heat capacity. 21 is heat capacity. 22 is calculation. 23, calculation. 24, 25, 29, 31, those are calculations. 32 is calculation. 33, okay, they say a quantity of ice at minus 100 and minus 10 degrees Celsius is heated until the temperature of the heating vessel is 90 degrees Celsius. Which of the following constant is not required to the vessel? 33. 33. 33 is option D. Specific latent heat of vaporization. Because see, they say a quantity of ice, ice solid, it melts to liquid. So vaporization no go dey involved. No forget say when you melt solid to liquid, na fusion, Fusin. When you melt liquid to gas, when you change liquid to gas, na vaporization. 34. Equal masses of copper and rubber are raised to the same temperature after some time. The copper was observed to be at a lower temperature because the specific heat capacity of copper is lower than that of rubber. 34 is option A. 35, calculation. 36, 37. What happens when a certain quantity of pure ice is completely changed to water at 0 degrees Celsius? what actually happens is that latent heat is absorbed, and again the mass remains constant and the volume decreases. 37 is option A. 38 calculation, 39, 40 calculation, 41, 42, 43. All these are calculations. 46. A drop of petrol. Let's touch 46 together. A drop of petrol makes a finger colder than a drop of water would be. Drop of water would be because the petrol would take, option B, petrol takes its latent heat of vaporization from the finger. The reason is that, see, as low as the temperature of the finger is, is actually greater, okay, than the low latent heat of vaporization that the petroleum needs to change to gaseous state. You get? So it takes its heat from there. So let me tell you, if you put your hand for petrol, waiting to make the petrol dey vanish, it's like your hand get enough heat. It's like you put you can try it out. Put a pan in fire, then put a drop of water. You see, you start doing shh, then before you know, the water will vanish. So in this case, your finger has enough heat to make the petrol vaporize. You understand? It's easy. 47, 48, 49, 50, 51, 52, 53. Pretty much everything here now is calculation. But 55. The quantity of heat needed to raise the temperature of a body by 1 Kelvin is the body's 55 is the body's heat capacity, option D. 56, 57, 58. The quantity of heat required to raise 58 again. 57 is option D. 55 is option D. 58. The quantity of heat required to raise the temperature of unit mass of a substance through unit temperature is 58 is option A. Specific heat capacity. 58 is option A. Specific heat capacity. 59, 60, and 61. They are all calculations. 61 also is a calculation. Alright, we've gotten to this point. Well done. The points here are not much, but anything you were able to jot down, I would like you to snap and send to us on the WhatsApp group for assessment. And if this is your first time coming across any of our clip and you would like to practice with us like this daily, different materials, I'll drop the link to the WhatsApp group in the description box of this video. You could click on that, it will bring you to our WhatsApp group. You could enroll and join us to help you prepare for your next exams. Thanks for watching. I'm Coach Ewing. I'd always say you win, you would surely win, you would always come out top. Just believe this.